Now, here on the other hand is the really important step that we need to go through. This is probably the most important feature of a test, but it is seldom checked. And when I say that, I mean it's seldom checked by people who read an article. Okay, although occasionally one wonders if the authors of the articles have actually looked into that, because sometimes one gets the feeling that they didn't. Okay, now when you're driving through traffic, there are certain laws that have to be followed, right? Otherwise, you're going to get a ticket, like this picture reminds you of. Well, the same kind of situation happens when you're doing a statistical test. Each test requires the variables and the data that are being used to meet certain conditions. Okay, so in order for you to have a driver's license, you have to have certain conditions satisfied, including physical conditions, age conditions, and the condition that you keep driving properly. Otherwise, your driver's license is taken away. So what you want to ask is, what are the conditions that are required by a given test? And then, of course, once you identify that, you want to ask, are they true in the given situation? So if an author in a certain article says that they use a certain kind of test, what you want to do is ask yourself, what is required for that test to be valid? And then following that up, was that met, was that true in the particular situation? If there is a discrepancy in that area, then the results of the test are really not reliable, not valid, and we might as well just ignore everything that they're saying. Let me give you some examples of conditions that need to be met. There are some tests where the sample data have to be collected independently of each other. So each observation has to be done independently of others. There are, on the other hand, some other tests, like matched tests, where in fact the observations get collected in pairs, or where in fact you do want to have a certain connection between different observations. Okay? On the other hand, keep in mind, and since we're doing inference, we're always going to assume that the data have been sampled according to some kind of probability sampling, okay, so that biases have been avoided and all that, all those requirements that comes from sampling in general. So I'm not going to repeat that on a regular basis. Another kind of information of requirement is that some tests require the variable to be continuous. Okay? So you may want to ask, was this variable actually continuous? And if it was not, can we really apply a test that is meant for continuous variables to something that is not continuous? On the other hand, remember, some variables are not continuous, but they can be considered as continuous, and the other way around. So this is one thing that, again, we're going to revisit as we go through the tests that have this requirement, and we're going to see how they're handled in that situation. Some other tests actually have an even stronger requirement that the data are bell-shaped, okay? So that the histogram of the data is not only that the variable is continuous, that its histogram follows a bell-shaped distribution, okay? So again, you want to ask, was that true in our case? There are also some tests where you're comparing several samples, and what the test requires is the variability in each sample should be the same, or if not the same, very much close enough to each other. Okay, so is that a requirement of your test? If it is, was it satisfied in the situation where it was applied? Okay, so these are just some examples of requirements that some of these tests are going to have. And here come to the last one, the robustness of a test. I'm not sure if you have heard that word before. Robust, usually associated with strong, with Superman, or maybe Statsman, who knows. But it has the same kind of meaning in statistical testing. In fact, even though it is an unusual name, but it's probably one of the most practical features of a test. What are we asking here? What we're asking is that we're going to reflect on the fact that in practice, the requirements that are needed for a test are almost never fully satisfied. We're talking about real life. We're talking about real data. We're talking about lots of limitations coming from our collection of data, which may make some of the assumptions, well, not quite truly acceptable. Okay? So what we're asking is, can the test still be trusted when its requirements are not fully present in the given situation? Okay? Another way to word it is, how far from the requirements can we go and still obtain a reliable p-value? Maybe not an exact p-value, but hey, p-values are never exact anyway, right? There is always all kinds of approximations going into the computation of a p-value. Right? But the idea is, well, can we deviate from the requirements, and how far can we deviate and still get a good answer? There are some tests that are fairly robust, so even if the assumptions, the requirements are not fully satisfied, they still work. In fact, there are some tests that have requirements which are so weak that are pretty much satisfied to an acceptable degree in all situations. Okay, so those are very robust tests. There are other tests that are very finicky. You move a little bit away from their requirements, and the p-value, you might as well guess at it because it's not valid. Okay. So this is a very important piece of information, and it needs to be taken into consideration. So those are the 4 features that we're going to be looking at, and we're going to now start looking at them in each of the major types of tests that we're going to analyze. Now keep in mind that there are literally hundreds, if not thousands, of different statistical tests. We're not going to look and not at nearly as many as there are, just maybe the 3 or 4 which are most commonly used, and just make sure that those ones are the ones that you get a good understanding on. And then as you develop your familiarity with these ideas, you can develop your own knowledge of other kinds of tests, or you can figure out what these features are for a test as the need arises when you see some unusual test being used in an article.